Today we'll be solving LeetCode 208 Implement Trie Prefix Tree. Let's take our time to understand it clearly. A trie is a tree-shaped structure where each node represents a single character, and a path from the root down to a node forms the prefix of a word. This means we can check prefixes very quickly by going down the tree character by character. So the big idea is that instead of storing entire words in something like a hash map or array, we break each word into characters and place them into a tree so that shared prefixes only need to be stored once. This makes operations like prefix lookup extremely fast. For this problem, we must build a class that supports three main operations. First, we insert a word into our trie. Next, we can search for a full word to see if it exists. Then we can check whether any word in the trie starts with a given prefix. To make these work, each node of our trie needs two things. We need a dictionary or a map that stores child nodes for each character, and we need a marker telling us whether this node represents the end of a valid word. Let's walk through how each operation works. When inserting, we begin at the root node. Then we move through the characters of the word one by one. For each character, if the character doesn't already exist as a child, we create a new node and connect it. Then we move into that child. After processing all characters, we mark the final node as a word ending so that future searches know that a complete word ends here. When searching for a full word, we again begin at the root and try to follow the characters down the trie. If at any point a required character doesn't exist, we can immediately return false. If we successfully reach the end of the word, we only return true if the final node is marked as a complete word. Finally, for the startsWith function, the logic is almost the same as search, except we don't care about the end of the word marker. As long as every character of the prefix exists in sequence, we return true. Now, let's go through the code. We begin by creating a node class. Inside it, we give each node a dictionary that maps characters to the next node. We set this to an empty dictionary when we create a node. We also add a Boolean field called isEnd, which starts as false and will become true only when a full word ends at this node. Next, inside our trie class, we create a root node. This root does not store a character, but it acts as our starting point for every operation. For inserting, we create a variable called node and set it to the root. Then we loop through each character of the incoming word. If that character does not exist inside node.children, we create a new node and insert it into that dictionary. Then we set node to node.children for that character so that we move deeper into the trie. After the loop finishes, we mark node.isEnd as true because we have reached the end of a valid word. For searching, we again start with node equal to the root. We loop through each character in the given word. If at any point the character doesn't exist inside the current node's children, we return false immediately. Otherwise, we move into the child node. After the loop, we return node.isEnd because only a node marked as a completed word counts as a true match. For startsWith, the logic mirrors search, but instead of returning node.isEnd, we simply return true once all characters of the prefix are successfully followed. That's because we only care that the prefix path exists. This problem highlights a common pattern in data structures where we store information in a layered structure instead of a flat one. In terms of performance, insert, search, and startsWith all run in O of n time, where n is the length of the word or prefix. The trie provides fast prefix operations because each step just walks one character deeper. The space complexity grows with the number of words and unique characters stored. And that's how you solve LeetCode 208 Implement Trie. Thank you for watching, and let's keep learning.